Hello and welcome to today's lesson. We're going to be covering topics under the standard 2.2b in Algebra 2, and then also topics under that study island topic, systems of equations and inequalities. This is going to be part one of two videos that work with and we learn about those topics and lessons. So you want to make sure if you're working on those topics and lessons that you will watch both videos. And we're going to be looking at building upon our skills that we learned in Algebra 1 on how to solve systems of equations and inequalities, and some of the problems are going to be just like the ones that you saw in Algebra 1. And so just remember as you're working through that you should be taking notes, and that way you can have those notes to refer back to when you're trying these problems on your own. And then you also can pause and rewind if I go too fast. And remember, you can even pause at the beginning of a question, work that question out, and then watch how I do it and see if we get the same answer, and that way you can learn from your mistakes. So I'm so glad that you're here, and I hope that you learned something new. Alright, so when you're solving systems of equations, there's three different ways that we're going to look at that you can use to solve them. The first way is graphing, the second way is elimination, and the third way is substitution. First, we're going to look at graphing, which just means you graph both of the lines. And when you do that, you can come up with three different situations. The first situation is that they cross at one place, and that's considered intersecting lines, and that means they have one solution because those lines are touching in one place. You could end up that the two equations graph the exact same line. So you have two lines over top of each other touching in a countless number of places. And so these, since there's an infinite number of places that they touch, you're going to have an infinite number of solutions. And then the third situation you could have is parallel lines. So those lines are never going to touch. So that's no solution. So this first equation, they give you two equations and they also graph them for you and wants to know what is the solution. Well, this is a pair of parallel lines. These parallel lines are never going to touch, so it's going to have no solution, letter B. So here you're asked to describe the solution of this system. And so here they intersect. So our solution is going to be this point here where they intersect. It's intersecting at the point 0, 6, and so that's going to be my one solution. So that makes my answer letter C. Next, we're going to look at how to solve using substitution. So to solve using substitution, you're going to solve one equation for y or x, and then you're going to substitute the expression from step 1 into the second equation and solve for the other variable. And then you're going to substitute the answer from step 2 into the revised equation from step 1 and solve. So let's look at what those steps look like in an actual example. Okay, this problem here asks us to solve using substitution. Just a heads up, on the EOI, the directions could ask you to solve using substitution, but you don't have to. If you felt comfortable solving these both for y and putting them in a graphing calculator and using that way to solve, you could do that. I personally think this is set up nicer to use elimination, so I would use elimination to solve for this, not substitution. But I want to show you an example on how to solve substitution, so we're going to use this problem. And so our first step is to solve either equation for x or y. I'm going to solve this second equation for x. And part of the reason that I'm doing that is because I know I only need to get my y answer. So if I solve one of the equations for x, the opposite, that's going to create less steps. But if you chose to do it another route, you would still get the right answer. It just might take you a few more steps, which is fine. And I'm also choosing the second equation over the first just because it has all positive numbers. Some people might pick the first because it has a smaller number. It's totally up to you. So here I'm going to solve it for x. That means I'm going to subtract 12y from both sides. And these 12y's cancel. And that just leaves me with 4x equals, and I can't combine a number and a y term. So I'm just going to have 112 minus 12y. And then I'm going to divide all these terms by 4 to continue solving for x. Those cancel, and I'm left with x equals 28 minus 3y. So my next step says that I'm going to take this equation here and substitute it into the other equation. So I rewrote the second equation, so I'm going to substitute this in to the first equation. So that means anywhere that there's an x, instead of writing an x, I'm going to write that 28 minus 3y. So I add that 4x, and then I just write the rest of it, minus 12y equals 16. And now I'm just going to have to solve for y. So the first step is going to be to get rid of the parentheses, so I'm going to distribute. 4 times 28 is 112 minus 12y minus the 12y equals 16. And then I'm going to combine like terms. So I have a minus 12y and a minus 12y on the same side. So when I combine those, they're going to stay the same. Signs stay the same. So it's a minus 24y. And then I still have the 112 and the equals 16. So the next thing I'm going to do is, it's a two-step equation. So I'm going to go ahead and subtract 112 from both sides. And that's, these 112s cancel, so that's mean negative 24y. And that's going to equal negative 96. And then I'm going to divide both sides by negative 24 as my last step. And that's going to be y equals positive 4, because 96 divided by 24 is 4. And the negatives cancel. And so since I just had to find y, I know my answer here is C. But if I needed to find x also, then I would just take that y equals 4 and substitute it in here. Take the 3 minus times 4 is 12, and then 28 minus 12 is 16, and that would be my x value to finish the problem. Okay, now we're going to look at how to solve problems of systems using elimination. So elimination, I'm going to arrange the terms in columns, and that's usually in standard form. And then I'm going to multiply to create opposite coefficients. And then step 3, I'm going to add the equations and solve for one variable. In step 4, I'm going to substitute the value into any equation and solve for the second variable. So here I'm going to use elimination to solve this problem. I already have the terms lined up, x's and x's, y's and y's equals numbers. So everything is lined up in standard form. So now I'm going to multiply to create opposite coefficients. Opposite meaning one's positive, one's negative, and they have to be the same number though. So I could either work with the 1 and the 4, the negative 1 and the 4 here, and the 4 and the 5. I'm going to pick these two because they're already opposite signs, so that's already been created for me. So in order to get 1 to be 4, I have to multiply it by 4. And then I have to multiply every term here also by 4 to keep it equivalent. So when I do that, my top equation becomes negative 4x plus 16y equals 60. And then my bottom equation, I didn't have to change, so it just stays the same. So I'm going to rewrite it underneath to keep everything lined up. And now I have my opposite coefficients. I have a negative 4 and a positive 4. So I can just go ahead and add those two equations. And so negative 4 plus 4x is 0. So those cancel out, and that's the whole purpose of opposite coefficients, is to get them to cancel. So that's a very good thing. 16y plus 5y is 21y equals, and then 60 plus 3 is 63. And then I'm going to continue to solve for y. So I just divide both sides by 21. And these cancel, and y equals 3. So I only have one choice here that has y equals 3, but I'm going to continue the problem just to make sure that I didn't make a mistake, and I'm hoping that I get x equals negative 3. So I'm going to go ahead and substitute this y in, and I can pick either equation. I'm just going to pick the second equation because it doesn't have a negative symbol, and that's what most students would pick. So I'm going to have 4x plus, and now I know that y is 3, so I'm going to put 5 times 3 here, equals 3. So I'm going to go ahead and solve that. First I'm going to actually do that multiplication. 5 times 3 is 15, equals 3. I'm going to subtract 15 from both sides. And 4x equals negative 12. And then I'm going to divide 4 from both sides, and they cancel, and x equals negative 3. Which was the answer that I'm hoping to get, so my answer is definitely D. When you have 3 equations and 3 variables to solve for, it's going to be a little bit different. First, you're going to solve one of the equations for one of the variables. So I'm just going to choose to solve for x in that top equation. So to solve for x there, I'm going to have to subtract 3y from both sides. And I'm also going to be subtracting z from both sides. And so here that causes those to cancel. And I'm left with just x equals on the left side. And then I'm going to take 2 and then minus the 3y minus the z because there's nothing there I can combine. So now I have this equal to x, so anytime that there is an x in my other 2 equations, I'm going to substitute in this entire equation for both of them. So let's go ahead and do it with the first one. I'm going to have 2, and then instead of writing x, I'm going to write the 2 minus 3y minus z plus 2y plus 4z equals 12. And then I'm just going to have to simplify that down as much as possible. So I'm going to distribute the 2. It's going to give me 4 minus 6y minus 2z plus 2y plus 4z. And now I'm going to combine like terms. So I'm going to take the minus 6y plus 2y is a minus 4y. And then the minus 2z plus 4z is plus 2z equals 12. Then I can also subtract 4 from both sides to combine those like terms. And they're going to cancel. And I'm left with negative 4y plus 2z equals 8. Then I'm going to have to do the same thing with the last equation. So I'm going to have a negative 2, and then I'm going to substitute in what I found x to be, which is 2 minus that 3y minus z plus 3y minus z equals the negative 11. So the first thing I'm going to have to do is distribute this negative 2. So it's going to give me negative 4 plus 6y plus 2z. And then I still have my plus 3y minus z equals negative 11. And then I'm going to go ahead and combine like terms. So I still have my negative 4, and then I combine 6y and 3y is 9y. And then I combine 2z minus z is just a plus 1z, or just plus z, and that equals negative 11. And then I want to add 4 to both sides. And these are going to cancel. And I'm left with 9y plus z equals negative 7. And so now I have my two equations with two variables. So it's like the system of equations that we just did. So I'm going to go ahead and solve this equation here for z. So that's going to be z equals -7 minus 9y. And I'm going to go ahead and take this, what z equals here, and substitute it in for z in my other equation. So it's going to be -4y plus 2, but instead of writing the z, I'm going to write -7 minus 9y. And it's going to equal 8. So now I'm going to go ahead and solve this equation for y. So my first step is to distribute the 2. So I'm going to have -4y minus 14 minus 18y equals 8. I'm going to combine my y terms on the same side, so it's going to be -22y minus 14 equals 8. I'm going to add 14 to both sides, and that's going to leave me with -22y equals +22. Then I'm going to divide both sides by -22. And so then y is going to equal -1. And I have my first variable out of 3. And I've already narrowed it down to A or C. So now I know that y equals -1. So I'm just going to go over here where it says z equals. And I have -7 minus 9y. But now I know that y is -1. So I'm going to go ahead and substitute that in. So that's going to be -7 plus 9, which equals 2. So z is equal to 2, and that doesn't narrow it down anymore, but if I go back up here to where I have it set an equation equal to x, I can go ahead and substitute what I know y to be and z to be. So I have z equal to 2 minus 3y, but now I know y is -1. And then minus z, which I know is 2, and then I can figure out what that's going to be. So it's going to be 2 plus 3 minus 2. 2 plus 3 is 5, minus 2 is 3. So x equals 3. So that's going to mean that C is my answer. Thank you for joining us today, and I hope you learned something new.